Hello again, and today we're going to continue our lessons about TouchDesigner SOP operators, and today our topic is again splines. Most of these operators are very old school, coming still from Houdini, and I don't know if you really will need them, but maybe. So let's start with several examples. Let me remember some basic theory about the splines. Splines are mathematical function, and very special for splines is that control points are not the part of the surface. So basically the different spline types like Bezier, NURBS, cubic splines, etc. are interpolation functions between the points, and they can share several points. Also very important to understand that actually, because it's parametrical, we can easily calculate u and v coordinate, or actually the coordinate itself is a part of the line of the surface. And also I just remind you that we cannot make T structures, T junctions using splines, we cannot make holes, but there are different tools to simulate that behavior. So that's what you need to understand working with splines everywhere. One example I want to show you how can we convert the regular polygonal line into splines. So let's create a model, and in model we can model geometry. So we can select different views using hotkey space 1, 2, 3, 4, build polygon or curve tool, and here we can select polygon, NURBS and Bezier. Also we can choose different versions using breakpoints, using CVs and freehand. So let's draw something freehand using polygons, and now we have one polygon curve with 117 points. We can simplify that geometry using the resample. Now we have 12 points. Let's split the interface to left right sides. Let's create some null on the end, visualize the display flag there, and switch the second part to the geometry viewer. Here we can open display option and make the visible points. I will simplify even more, and I will maintain last vertex, so we have very basic shape. From that polygon geometry, basically we can achieve the creation of the spline geometry using different ways. We can use, for example, convert. Let's convert that to Bezier, or let's convert it to NURBS curve. And you can see in that case the original polygon points behave like a control vertices. Second way is to use a fit operator. And fit operator can create a geometry using two different ways, using approximation and interpolation. So basically both results are quite different from the convert. So if we use interpolation, all that points quasi belongs to the surface, and the new curve will create it by interpolating their position. So on the end we will receive the new control vertices corresponding to that shape. Other case, approximation, it's also use the original points as a surface points and also create a new control vertices using just different algorithms. So here we have two pages for approximation. We have a smoothness here. We have a multiply nodes, tolerance, and in case we choose interpolation, we also can play with it. And here, in case of interpolation, you can see U diet parameter is chord length or uniform. Next step, what I want to make, I want to use function of the splines to generate the smooth interpolation lines between the existing curves. So I will create another curve using circle. I will switch it to the NURBS curve. I will make open arc. I will change the radius. Something like that. I will open the line. And something like that. Also I can reduce amount of points on divisions. And now, in order to join these two curves by interpolation line, we can use the FIllet operator. FIllet is especially created to make the smooth transition between ends of two lines or surfaces. So basically I will show it on a surface level, but you can also deal with surfaces. So on the end you can see what is created. Okay, that's obviously connecting the wrong positions, and we can control it by two ways. One way is to change left U position, but also we can just invert the U coordinate direction by using primitive SOP. And here we can check the face options, and in vertex we can change it reverse U and connect it here. Same we can create for the second input. And now you can see that it's connected to the proper lines. So let's check what kind of options we have in FIllet. We have width, we have scale, we have right U and V position, we have offset, so that using offset we can make this interpolation more long. Using scale we can increase, basically it's scaling the tangential from the last surface point. Same here. And combining these two options we can basically create different shapes. Also we have freeform, convex and circular. So maybe let's create another circle on the top and finish the shape. So now we can make a very small NURBS curve and use it as a open arc, and using transform and move it to make the top part of our vase. Okay, now we can move a bit on the side and work with open arc parameters, something like that. And now we can create a second fillet and finish the shape. And now let's think how we can join these two guys together to make a final shape. So I would say makes sense to connect it in the proper direction. So after the 6 point it should increase. So that's why I will bring it here. Also, before we're going to use the next fillet, I want to show you another cool operator which is called Align, which can visualize how these two shapes are aligning and where is the which geometry. So we can bias between original positions and blended positions, and we can change the part is aligning. So also good to know actually. Okay, now I will use another fillet and just connect this line and this line, and here we can see that we connected on the wrong direction, so maybe we don't need to connect to this primitive. And on the other side we can control it using the right U parameter, and now we should obviously control the direction, so we make it also positive, control the shape by the left right offset. Now we can merge these geometries together. We have basically three NURBS curves. We can visualize them using display options and primitive numbers. We can delete here the geometry number 0 using the group parameter, and then we can merge these two guys together. And actually, in order to receive the final shape, we need to have all the lines in the same direction. So we obviously have one line going in wrong direction. So let's check line number 3. So we can use a primitive SOP again. Select the group number 3. Go here, change the reverse U, and the last, we have now 5 NURBS curves, and using the join operator we can create the final geometric shape. Maybe we should do it even before. Here, for now, we have here two NURBS curves. Let's make a join here. So we have now one line. So let's find a way how to solve it. Obviously, the problem is in the ordering of the lines. For that reason, we can actually recreate that geometry. So if I will delete then line number 1, and then I will delete everything else, then merge them together here. Now I will have the proper ordering. Okay, let's take the join here, and voila, it works now. So it looks properly, and we can do it on the second side as well. So basically we just reconnect it here, remove primitive, and finally we have a ready shape. And with this geometry currently we can do something cool, like making the revolve operation, increase level of details, something like 50, and we can also make some cap here. So let's make a cap operator, and we can check cap U rounded. So now you can see what is created. That shape on the end of the line was integrated here, and we can use scale to make it smaller, and we can also build in the curve operation to cut it a bit. So for that we should use the V, I think, and we can cut the hole. Now we have a ready vase shape. Let's continue to think what we can do with that. I think makes sense to embed some resample or refine before the revolve operation. So we're using now already operation we know from the last lessons. Now we can even make more divisions to make it much more smoother. Use arc length spacing. We can control the part where we're going to refine. The rest we will discover in the next lesson. Follow us on all social networks, and if you go to the howtotouch.com, you can subscribe to our newsletters, so you will be updated about our free lessons, workshops, and all events we organize. Thank you, and see you soon.